Hi guys, Mrs. Robinson back to work practice benchmark chapter 10 with you. Now this will be a super short test. You only had 4 sections just this week. 10-1, 10-3, 10-6, 10-7. Only half the chapter or half the sections. So this will feel more like a quiz. All right, only 8 questions. Now, these are just a sampling of some of the topics that are 7th grade standards. And last week in Module 9, I gave you a quiz on some data and statistics and data from Khan Academy. Those are more 8th grade standards. Now, both will repeat in Math 1, but just to give you a little bit of the statistics and data from both 7th and 8th grade standards, you just have 2 really quizzes. This is called a benchmark, and it will fall under your benchmarks, but it's short like a quiz. So let's go over it. Measures of central tendency. Let's look at the first one. Mean, median, mode, and then there's also range, all right? Measures of central tendency are measures of the middle. There's different ways to measure the middle. If there's an outlier, that can throw off your average, but it wouldn't throw off the median if it's all collected together. Mode would be the number that occurs the most, so it really depends on what you're looking for. Sometimes you'll hear the average housing price is 400,000 for the area, but the average housing price can be thrown off by a house that's in the millions. Okay, so maybe the median housing price would be more accurate, because if you have a house that's like $10 million and the rest of the homes in the area are in the 500,000s, that $10 million house will throw off the average or the mean. So it depends on what data you're looking at for which measure you use. Mean is the average. Median is the middle number. Mode, I remember for MO for most. It's the number that occurs most often. And the range is the difference from the least to the greatest. The mean, I can remember mean is average, and this is how I remember. If I have to take the average of the amount of money my brother has and I have, we add our money together and divide by 2. And I remember my brother is mean. So that's how I remember average. All right. Median, the middle, and the mode is the most. All right. Let's go ahead and take these numbers and find our measures. I always reorder my numbers from least to greatest, especially if I have to find the median or the middle. You have to do that. So let's go 4, and then 6. Nope, just kidding. Let's go 4, and then 5. So 4, and then 5, cross them out. Then 6, then 8, and then 12. All right, so there's my 5 numbers. Let's go mean first. Mean is the average. So to find the average, I add up all the numbers, and I divide by the number of numbers I have. I have 5 numbers, 1, 2, 3, 4, 5. I'm going to add them up and divide by 5. And you can use a calculator for this. Go ahead and add these up and divide by 5 and find your average. All right, when I do that on a calculator, I get 35. When I add those up, divide by 5, I'm going to get 7. So my mean is 7. My median is the middle number. So since I wrote these in order from least to greatest, it's literally, since I have 5 numbers, it's my middle number. Now if I had 6 numbers, I would have to average my 2 middle numbers, but I don't. So my median is 6. My mode, the number that occurs the most often, well, each number only occurs once, so I don't have a number that occurs the most. So I'm going to put none for that. All right, and which one of these is that? The mean is 7, the median is 6, the mode is none, so it's C. All right, next. All right, which measure would change the most if an outlier was removed from this set of data? An outlier, like I talked about before, with a house that's in the millions and the rest are in like the $400,000 or $500,000 range, that would skew my average. So I know an outlier is going to mess up my mean for sure. The median, if I put these in order from least to greatest, the outlier doesn't really affect my median or my middle number so much. The mode, an outlier wouldn't affect the number that occurs most often either. the range, an outlier would affect my range, the difference from the least to the greatest. So let's go ahead and see which one it affects the most. So I'm guessing it's either going to be, and it doesn't really affect the mode. So it really only affects the mean and the range, an outlier. Let's look at this set of data and write it from least to greatest. 48 looks like my least number, and then I like to cross it out after I've used it. Then 75. Then it looks like 84. Then 86. Oops, I forgot the 80. Let's squeeze the 80 in there. 80, 84, 86, then 88, then 90. Now if I wrote this all on a number line, this 48 would be way down here. Then 75, 80, 84, 86, 88, 90 would kind of be chunked together. So I can see easily without even doing any analyzing that this is my outlier. Now if I drop off this outlier and I change the average, let's go ahead and find the average with the outlier. So add up all your numbers. 1, 2, 3, 4, 5, 6, 7. There's 7 numbers. So add up the numbers and divide by 7. I'm going to go ahead and do that and see what we get. All right, when I add up all these numbers and divide by 7, I get about 78.7. That's my average. Now let's drop this off and figure out what the average is. Add all these up, and this time I only have 1, 2, 3, 4, 5, 6 numbers. I only have 6 numbers, all right? Add those up and divide by 6 and see what you get. All right, when I do that, I get 83.8. So I can see this outlier affected my average. Now I can find the difference between these two to see how much it affected my average. If I subtract 78.7 from 83.6, it affected my average by about 5 approximately. Okay, so it did affect the mean by about 5. Let's see how it affects the range. Now the range from the least to the greatest, so I'm going to go 90 and subtract off 48. My range from 90 to 48, that's a 42 difference. Now if I get rid of this outlier, my range would be from 90 to 75. Now if I go ahead and subtract 90 from 75, I'm going to get 15. So that's a huge difference. The range is 42 or the range is 15. That's way bigger than a 5-point difference. That's a lot. So which measure changes the most if you get rid of the outlier? It's the range. The range changes the most. When I do the average and add these all up and divide, it seems to average this lower number out more than just counting the range. The difference from the least to the greatest is going to be really affected by this particular outlier. Okay, an online store has daily sales of all of these amounts. Which measure of center makes the store appear the most profitable? So I'm either going to say the median sales for the day, or the mean sales, the average sales for the day, or the mode for the sales of the day, or the range for the sales of the day. Which makes the center appear most profitable? Well, let's find all these measures and see which one seems the best. So if I'm going to find the mean, I just have to add these all up and divide by the number. So 1, 2, 3, 4, 5, 6, there's 7 of them. So for a week of sales, if there's 7, I'm going to add those all up and divide by 7 instead of writing them all out. So go ahead and do that. Add those all. So to find the average, I added these all up and divided by 7, and I'm going to get an approximate. It's about $28,915.42, but we'll just go $28,915. Now the median is the middle number, and in order to find the median, I need to order these from least to greatest. So let's go ahead and rewrite these and cross them off. So we're going to go 25,228, that'll be your first number, then 25,696, then let's see, let's go to 27,604, $27,604. Then let's go to 28,000. 29,000. I'm running out of room because I wrote too big. 29,080. And then I'm going to just squish down here. Let's see. And then 33,400 happens twice. 33,400. All right. So we have to find the middle. There's 1, 2, 3, 4, 5, 6, 7 sets of data. So the middle would be 1, 2, 3 on this side, 1, 2, 3 on this side. This will be your middle number. Since it's an odd number, the middle is right in the middle. If it was an even set of data, you'd have to find the average of the two middle numbers. All right, 28,000 is our median. Just straight up 28,000. So the average or the mean gives you a little bit higher number, 28,915. So that looks a little bit better. The mode, the number that occurs most often, this is the only number that repeats. So that number is the mode or the number that occurs most often, 33,400. Well, the mode is looking like it's going to make the store appear most profitable. The range, the difference from the least to the greatest, well, I'm just going to go 33 to get the range. I'm going to go 33,400 and subtract off 25,228. And that's going to be my mode. So if I go 33,400 and subtract off 25,228, I'm going to get 8,172. So obviously not the range, because the difference between the least and the greatest is not that big. $8,000 from the worst day to the best day of sales, right? $8,000 change. So not that. So the mode or the number that occurred the most will make the store look most profitable. That one would. All right, the table shows the number of students who attend the Spanish club meeting during the school year. To the nearest tenth, what's the mean absolute deviation of the set of data? Now the mean tells the average. The mean absolute deviation tells you how far or what's the average of each point to the mean. Meaning each one of these points, what's their average distance to the mean? Meaning how good is your mean? So if your mean absolute deviation is a small number, that means all your points are really close to the average. If your mean absolute deviation is a big number, that means all your points are not close to the average. They vary, big and small. So heights might be one. Like if you take heights of an average adult, girls' heights tend to be closer together and men's heights tend to be further apart, because you can have a 6'7" man and a 5'4" man, and women tend not to be as tall as men. All right, so that's what this tells us. What's the average distance of each point from the average? So first thing you have to do is find the average. So you're going to add up all your points, 14 plus 21 plus 17 plus 26 plus 13 plus 20. And there are 6 points, so you divide by 6 and find your average. That's your first step. All right. Ooh, whoops. I missed where I was. Okay. And that average, if you add these all up and divide by 6, you get about 18.5. That is your mean or your average, all right? 18.5. So then what we need to do is find what's the difference from each point to the average. And we're going to find the absolute value of that, meaning it doesn't matter if it's positive or negative, just what's the difference. So we're going to go 18.5 minus 14. What's that difference? Then 18.5 minus 21, what's that difference? And so on for each point, minus 17. And I'm putting these bars here, meaning the absolute value, meaning I don't care if this difference is positive or negative. All right, 18.5 minus 26, 18.5 minus 13, and then the last one, 18.5 minus 20. All right, so I have to find the difference of each of these, and let's just go ahead and do that real quick. I'm going to pause it and write down all the values. Okay, when I do all the subtractions, these are the values I get. 18.5 minus 14, I get 4.5. 18.5 minus 21. Now 21 is bigger than 18.5. I still put a positive 2.5 because I'm looking to see how do I get from the middle here. This way I go up to get to it. This way I go down to get to it. I don't care. The middle, some are going to be higher and some are going to be lower. So I'm going to keep these all positive values. I'm not going to write negative here. That's why we do the absolute values. I just want to know the distance, the difference between these two, and the distance that it is from the middle. So here is the distance from the middle. Obviously, this one is furthest from the middle. It has a difference of 7.5. So what I'm going to do is I'm going to find the average of their distances. So what I do is I average these. So I'm going to add these all up together and divide by 6. So I go 4.5 plus 2.5 plus 1.5 plus 7.5 plus 5.5 plus 1.5. I add those all up together and find their average. So go ahead and do that on a calculator. All right, when you do that on a calculator, you get, I'm going to round, so I'm going to do a little approximation. You get 3.83 repeating, so we'll just go 3.8. We're going to round it to 3.8. So the average difference from the middle, which is 18.5, to each point, the average difference is 3.8 of all of my differences. Now, if that number was huge, that would mean I would have a wider range of data. So 3.8 is pretty good. And that would be C. That's your mean absolute deviation. So once again, with mean absolute deviation, first, find the mean. Second, find the difference from the mean to each point. And then third, find the mean of the differences. And that is your mean absolute deviation. Okay, Bailey tossed a coin 20 times. The results were 12 heads, 8 tails. What's the experimental probability of tossing tails? Okay, we want to know experimental. Now the difference between theoretical and experimental. Theoretically, if I toss a coin 20 times and there's a head and a tails, theoretically half would be heads and half would be tails. So 10 would be heads and 10 would be tails. So theoretically it would be 10 out of 20 or a half, right? Experimental means I actually did the experiment. I tossed them 20 times and this is what I ended up with, 12 heads and 8 tails. So what's the experimental probability of tossing tails? Now remember, probability is your favorable over your total, okay? So favorable meaning what I want. Now what I want is tails. So the favorable I actually got was 8 tails, not 10. And the total was 20. So my experimental probability wasn't 10 out of 20, it was 8 out of 20. That's what I actually got, 8 tails out of 20 total tosses. And you can reduce that. Let's see, 4 goes into 8 and 20. 4 goes into 8 2 times, 4 goes into 20 5 times. So my experimental probability would be 2 out of 5. Favorable at a total, 2 out of 5. All right, let's look at the next one. A spinner like the one shown is used in a game. Determine the probability of each outcome if the spinner is equally likely to land on each section. Okay, so I spin it, it's not leaning to one side or another, it can land equally on either of these sections. So if you played a board game, express each probability as a fraction and as a percent. Then describe the likelihood of each event. So right, it's either impossible, I mean I can't even get it. It's unlikely, and unlikely would be like less than 50%, right? Equally likely would be right at 50%, and likely or certain would be a really high percentage, right? So what's the probability that I get a 15? There are 16 here. Now remember, probability is the favorable out of the total. Now my total is there's 16 numbers I could land on. 16 is my total. My favorable, what I want, the probability of 15 is I want to land on 15. So how many times could that happen? It only happens once right here. So 1 out of 16 would be my probability. Now if you want to turn that to a percent, you go 1 and divide it by 16, and you're going to get 0.0625 as a decimal. Move it over 2 places for the percentage, 6.25%. Okay, so is this unlikely, equally likely, likely, or impossible? Likely or certain. Certain means I would get 100%. That would be certain. Impossible would mean 0%. Now I'm going to say unlikely. It's only 6.25% chance that I land on 15. So I'm going to say unlikely. It's not a very high percentage, so I would pick A for this. Unlikely. All right. Okay, we're back to the heads and tails. All right, guys, let's go ahead and look at number 7. Bailey tossed a coin 40 times. So back to the coin tossing. The results were 26 heads and 14 tails. Which statement accurately compares the theoretical and experimental probabilities of tossing tails? Now look here, 14 tails is what got tossed. So let's look at the experimental first. Okay, remember, favorable out of total is our probability. Okay, the favorable, when we're looking at tails, the favorable, what actually happened was 14. And the total is 40. Now that's what happened. That was what happened in our experiment. Now theoretically, if I toss a coin and there's heads and tails, half of them should be heads and half of them should be tails. So theoretically, 20 out of 40 should be tails. That's what should happen in theory. When I actually did the coin toss, I got 14 out of 40, so it wasn't super awesome. So which statement accurately compares the theoretical and the experimental probability for this case? Well, the theoretical is bigger than what actually happened, the experimental. So theoretical would be greater than experimental. Okay, so theoretical is greater than experimental. That's what happened right there. All right. Okay, looking at the last one. This table shows the results of an experiment in which the spinner was spun 50 times. So make sure you read that part, otherwise this won't work. Find the experimental probability of each outcome. So you had a spinner 1 through 16, like on that last one. We spun it 50 times. So remember, probability is favorable out of the total. So let's go ahead, and we know the total is 50. Let's write that here. Now, the number on the spinner is 1, 2, 3. The frequency that occurs is here in this chart, okay? 9 occurred 1, 2, 3, 4 times. 10 occurred 2 times, all right? So this is what actually happens in the experiment, not the theoretical, okay? Now we want to know, number 8 wants to know, what's the probability that I spin less than 4? Okay, so what is less than 4? It doesn't say 4 and less, it just says less than 4. So the numbers less than 4 are 3, 2, and 1. These are the numbers less than 4. What's the probability that I get less than 4 when I spin? Well, 3 occurs 3 times, 2 occurs twice, and 1 occurs 1, 2, 3, 4 times. So 4 times they spun and got a 1. Twice they spun and got a 2. 3 times they spun and got a 3. That just happens to match up. All right, so how many times did they spin and get a 3, 2, or 1? Well, count it up. 4, 5, 6, 7, 8, 9. 9 times. So when does it occur that I spin less than a 4? It occurs 9 times. How many times did I spin it? 50. So 9 out of 50 would be the probability that I spin less than a 4. 9 out of 50. And that is A. All right, guys, that's how you would do this practice benchmark. You have a really short benchmark, so get that done. Remember, probability is favorable out of the total, all right? And then count up what your favorable is. Good luck, and email me if you have any questions.